In example 4, we have another example where a Pythagorean theorem can be applied to a related rates problem. So Joe is driving west at 60 kilometers per hour and Dave is driving south at 70 kilometers per hour. So let's start with a diagram of that. So here I've got the diagram set up twice because I know I'm going to need both diagrams. In the first case, I'm going to set it up as the generic diagram. And then in the second case, it will be specifically for this moment in time that it'll mention in the latter part of the problem. Okay, so we'll label this first diagram with some variables. So we've got both cars are approaching the intersection of the two roads. So Joe is driving west, so here's Joe right about here. And then here is Dave when we first start, okay? Both cars, okay, so at what rate is the distance between the cars decreasing? So we're gonna need this piece right here. So I'll call this Z. And J and D are just to help us remember who's driving in what direction. But I'm still going to stick with the horizontal component as X and the vertical component as Y. I also know that Joe's speed, which is going to be dx dt, is going to be equal to 60 kilometers per hour, except what's happening is that this horizontal distance is getting smaller as we approach as Joe drives closer and closer to where the two lines intersect. So since it gets smaller, the rate of change is diminishing by 60 kilometers. That would be minus 60 kilometers per hour, so that'd be minus 60. And then we've got dy dt, which is going to be Dave's speed. And similarly, this vertical length is getting smaller with each passing unit of time, and so therefore y is decreasing by 70 kilometers per hour. Okay, so where do we go from here? I think we're ready to set up our equation. So the equation is going to go like this. It's going to be x squared. Maybe I could set it up right here actually. X squared plus y squared equals z squared. Okay, and from our previous example, we know that ultimately this is going to end up being 2x dx dt plus 2y dy dt equals 2z dz dt. Okay, and then we know the 2's cancel. And we're looking again at the rate that the distance between the cars are changing, so that would be the dz dt. Maybe this time, unlike in example 3, I'm just going to start by rearranging, right? So dz dt is going to be equal to, well, really it's going to be x dx dt plus y dy dt. And that's all going to be divided by z. Okay, so essentially, if we're looking for this, all we have to do is divide both sides by z, and we're there. Okay. Good. So now we just need to use this related rates equation, but chances are good that I don't actually have all of the values that I need. So let's just see what the second part says. At what rate is the distance between the cars decreasing when Joe's car is 0.4 kilometers? So Joe is this way. So we've got 0.4 kilometers here. That's x. And Dave's car is 0.3 kilometers away from the intersection. Okay, so I guess what we'll need also is z. Now this is a 3, 4, 5 triangle, so I think it's easy to just say z is equal to 0.5. Okay, and if you weren't sure about that, you could always just simply use Pythagorean theorem. But 3, 4, 5 triangle, that's pretty straightforward. Okay, so then I'll just plug everything into the related rates equation and away we go. So dz dt is equal to x, which is 0.4, times dx dt, which is negative 60, plus, oh, and unlike example 3, we're actually given everything in terms of consistent units. So this is kilometers per hour. Whereas before, I think in example 3, we were given like minutes and also kilometers per hour, so we had to do a conversion. So 0.4 times negative 60 plus 0.3 times negative 70, all divided by z, which is 0.5. Okay, and you can see that this is going to be a negative answer, which makes sense because that means that the rate at which z is changing is that it is it is decreasing at that particular rate. Okay, so taking out the calculator, we get negative 45 over 0.5, which at the end of the day equals negative 90 kilometers per hour. Okay, so the negative just means that the distance is decreasing, that they're actually, the cars are drawing closer together. Okay, so distance is diminishing between cars. Okay, that's it.